It's all yours.
All right.
Okay, so guys, so I want you to look at your data. And so first is, were there any like observations that you made or things that surprised you? What did you notice while doing this activity?
In part 2, it surprised me that the final temperature was so close to the temperature of the bolts.
Okay, so the temperature was closer to the bolts. When we mix them together. What do you think that tells us about the bolts versus the water?
I don't know.
Okay,
I think the bolts are stronger than the water.
Okay, so they're stronger. We're going to talk a little bit more about what that means. Okay, what did we notice in part 1 when we mixed hot and cold water? What affected the final temperature? So what did we do the first time? So first time we mixed hot and cold water, and we mixed 25 grams of each, right? Okay, so what happened to our final temperature in that? Was it like closer to hot or cold, or was it in the middle? Okay, so it was in the middle first time. But then, what happened as we changed our amounts of hot and cold water?
Well, when we had more masses or more water that was hot, then the final temperature was a little warmer. And then in the third part, when we had 50 cold and 25 hot, then it looked to be a little bit colder.
Okay, cool. So we're saying, so if we change, like we're saying, if we change the mass, if it's more cold, it's going to be colder, which is kind of what we expect, right? Okay, did that same pattern hold true when we did the bolts? If we had similar masses, did the temperature go to the middle? No. Okay, so when we had the similar masses of water, it equaled out, which is what we would expect to happen, right? Okay, but now, this is kind of what we're getting back to the stronger idea that even though the bolts and the water had the same amount of mass, there's something else going on here that messed with it. Okay, so eventually we're going to get to an equation for this, but so we're talking about heat transfer and how heat moves through different materials. So far, what have we seen that are two variables that affect how the heat is transferred?
Mass.
Okay, so we have mass. Okay, and those are another one that we talked about.
So the bolts?
Yeah, so we have like our material, right? Okay, so for a few minutes, I want you guys in your groups to try and come up with an equation of how these relate to temperature. Okay, so we have mass is a variable we know about. Material is one of the variables. It also depends what temperature we're starting at, the temperature of the water. Okay, so I want you to use these three and kind of think of what you would think the equation would be. Okay, and it doesn't have to be right. You don't even have to use, you can use whatever symbols you want for these, but come up with what you think the equation would be to describe heat transfer as it flows from one thing to another. Okay? So just talk about these variables, how they relate to each other, which one's the most important, and how you think they work together. Take like 1 minute if you guys want to come up with an idea.
I think they're equally important. That's my thought.
Okay. Yeah, because like in the bottom part 2, I guess it had 25 cold and 25 hot was the same, but the bolts are the same, 25 and the final here is 46, whereas those used to be like 25 pounds, and that would be 8 degrees, and 25 cold and 46 degrees. So it kind of looks to me like the bolts are a little bit more important.
Sure, the material.
Yeah. But you guys have any idea of like what the that might be. Something where to start with.
So maybe multiply the mass times the temperature, and then add it to the mass times the temperature of the second material, and then divide it by something.
Well, maybe.
I was thinking like averaging in my head, but that wouldn't make sense.
Okay.
But we need some number to represent the different materials.
Like 1, 2,
They change for every material.
like the density. Or the atomic number we can use.
There we go. And we have to get the
Wait,
atomic
do you
number.
know like which elements there are? It just says metal bolts, so.
So is it really specific? Like you could have like number like this is for metal bolts or this is whatever material you plug in. Because
It's
you
like a
can
variable?
yeah. So you can make up your own like X, Y, Z, J, star, whatever you want your variable to be.
okay.
I'm gonna get a pencil.
So, and then when you have your idea, and it's okay if you have different ideas, you can come up and write them on the board.
Okay.
Is it okay if we write on these?
Okay.
Okay.
Cool. So yeah, it's you know what it's right.
Oh, okay.
Okay. Just come up and write. Yeah. Cool.
No, you can't copy it.
Oh, wow.
Are you gonna second her vote?
No, yeah, looks pretty good to me.
Okay.
Pretty
Just
solid.
does your group have any other ideas? Or are you guys all going with Kim's idea?
Yeah, Kim's pretty good.
Okay.
What's yours?
That's still, I don't have G plus B.
I'm
right
still
now.
working.
So are you just adding them together?
Yeah.
What approach are you taking,
I'm
Spencer?
not sure yet.
Are you multiplying or adding or she's got a little bit of all of it? So are you just multiplying them straight across? Or do you have other factors in
Straight across.
it? So if we go off her thing, would you have just x times y times z? Okay.
Okay.
So x times y times z. What about you, Sam? Are you somewhere between those?
Could
let's see.
combine.
Ooh.
Okay.
Let's see, so maybe just something simpler. I think that the temperature might just equal the material divided by the mass.
Okay.
So I guess Z equals X over Y,
Z.
if we're keeping our variables the same.
So mass over material or material over mass?
Material over mass.
So y over mass. Okay.
Yeah.
Okay, cool. So, I understand. So you guys are getting on a good start here. Okay. So obviously these different variables are going to affect our final outcome. Okay. So here's what our equation actually look like. Okay. So you're saying like obviously we have mass and material working together. Hey, you guys are close.
Hey, it looked
Okay.
like the third one, right? That's what you're gonna say?
Yep. Good.
Oh,
No.
okay.
Okay, so so in chemistry, we have a thing called Q, and this is what stands for the amount of heat being transferred. Okay, and then we throw in our math, and then C, and this is what you guys were getting closer to. C is tied in with our material. Okay, so there's kind of like density or atomic number, like you guys heard earlier. There's a number C that is specific to each material. Okay, one number that you'll want to know is that the C for water is 4.184. Okay, and we'll be using this number a whole lot over the next couple of weeks, okay? And then the last part of it is we throw in our temperature. So we're gonna have the temperature, and this, have you guys seen this before in your math classes? So this means delta, so this means the change in temperature, okay? And Kim was on to a good point that this equation, sometimes we don't usually ever combine it all together, but you sometimes have to run through this equation twice if you have lots of different materials. Okay, so we'd have to, like for the ones with the metal bolts, we'd have to do this once for water, and we'd also run it through again for the metal bolts because they'd have their different C's. Okay, so we use this a lot. So heat capacity, like you're saying, and so this heat capacity is what Q stands for. And this is kind of that stronger thing we're getting to, that certain materials can transfer their heat better than other ones. Okay, like we're saying, we've all been able to, if you feel like a metal, usually it feels cold because that metal is pulling the heat away from your hand. Another example, if you ever notice, if you open the door to your oven, okay, the air inside the oven and the metal is all at the whatever 375 degrees you're cooking your cookies at, right? But does the air burn your skin? If you reach inside to grab your pan? If you grab the metal pan, are you going to burn your skin? Yeah. And so that comes back to this heat capacity idea. That air has a very low heat capacity. It cannot transfer its heat very well. So that's why you don't get burned by just sticking your hand into the hot oven. But metal has a very, very high heat capacity. So making it stronger than water, meaning that it can transfer its heat more effectively than water or air or other substances can. So that's why as soon as you touch the metal in the oven, your hand's going to get burned. Okay, so we use this a lot in different materials, and we have a lot of more hands-on experience with this than we probably think. This has a lot to do with how we insulate our homes, your cars, things like that. Okay, so we're going to do a practice problem with this equation. Okay, so we can work on this in our groups. So we're starting with 2 grams of water. And this one, we're only going to have one material. So we're going to work on the 2 material step questions tomorrow. Okay? And it goes from 10 degrees Celsius to 25 degrees Celsius. Okay? And I was saying this is going to be our C. You want to remember that number? So I'm going to write out your equation and see if you can figure out what the so looking for the amount of heat transferred. Okay? In that process. Calculator. Okay, so how did you guys set up your equation?
Okay,
So
so
Q equals, what did you say?
so what I did is for M being the mass, I plugged in 2 milligrams H2O. And then there was C, so C was the material, and you just had it already on the board, so 4.184. and then times the change in the temperature, so 10 to 25 is 15 degrees.
Yeah.
Times
15. Okay. And then what did you end up getting for your answer?
So I ended up getting 125.52.
Is that what everyone else got? Click on that one. Okay, so yeah, so this one, this is just kind of the most basic first step of our equations. Like I was saying, we'll be getting more into this with if we're comparing other materials, we'll be doing with things besides water and other liquids and how those absorb their heat. This is kind of where we start, is we're just, and we'll learn how to find C. We'll be doing that in a lab later. But this is kind of where we're going for the next part of this unit, about heat transfer, which really we know that heat is type of energy. And cut. Thanks, guys.